In this video, we'll talk about the sensors in factory I/O. If you see this palette, if you navigate to sensors here, you will see several sensors listed here. So we have capacitive, diffuse, inductive, light array emitter, light array receiver, retroreflective sensor, and reflector. All right. Now, if you are aware of sensors, we use sensors to detect the physical presence and absence of the object and convert that into electrical signal. All right. So we have various different types of sensor to detect different objects. Well, let's see. Take the first example, capacitive sensor. Now, capacitive sensors are those which are generally used to detect non-metals. All right, although it can detect any material, it can detect metals as well as non-metals, but generally it is used for non-metal. So here we have a capacitive sensor, and it has two types of output. One is discrete and one is analog. Discrete will tell you whether the object is here or not. It will just give you a high or low signal. If there is an object, it will give you a high signal. If there is no object, it will give you low signal. That is a discrete. All right. If you make it to analog, now it will give you a variable signal based on the proximity of the object from the sensor. For instance, it has an approximate range of 100 mm. All right. So it will give you 0 to 10 volt based on the distance of the object from the sensor. Okay, that's a variable type of output. We'll see that its application in one of the environment. This is a capacitive type. It can detect metals as well as non-metals. All right, then we have a diffusion sensor, a diffusion type of sensor. Now, diffusion types are used, these are having a higher range than capacitive, but these can also be used for measuring metals and non-metals as well, because this is based on light principle. We also call it photoelectric sensors. So I can show you some example here. It has an emitter and has a receiver. Okay, so the light is emitted by this column here, and when there is any object, it reflects back to this light, this emitter, receiver. This is emitter and this is receiver. So that's how it detects that there is an object in front of this sensor, and it has range higher than the capacitive sensor, generally up to 1 meter, 1.5 meter. All right, and it generally has just one configuration, just on and off, discrete type of sensor. Okay, then third type we have is inductive sensors. Now, inductive sensors are used to measure typically conductive materials, or you can say that metallic materials. All right, because this works on the principle of eddy currents. So what happens when inductive sensor is activated? It has an electromagnetic field outside it. So if there is any conductive material pass across this field, some eddy currents are produced along the side of the material. That affects the EMF around the sensor. So we have some operation amplifier inside it, and with some comparator signals which sense that there is an object because its field is disturbed. So it detects that there is a metallic object in front of this one. Okay, so we have three types of sensor. We'll be discussing capacitive, diffuse, and inductive. We also call it photoelectric diffuse. All right, so let's see an environment where we have created a scene in which we have installed all the sensors, and let's see it's working. So I will just go to the open and open the sensors. There we go. So this is a small environment here. So what we have an emitter, then we have a conveyor, then this is a bracket which we have discussed before, and we have installed two diffuse sensors here, two photoelectric sensors. All right, then this is a light array emitter and receiver. This we will be discussing later on. And this is some aligner from where the box will be aligned. This is a receiver. So first let's understand the working of diffuse sensors here. Okay, so I need to build a dummy connect IO logic. So what I'm going to do is I'll go to the tags and I'll take first factory IO running. I just need to run a conveyor. So build conveyor 1 and 2 and 1. I need to activate the conveyors, and I need to activate the emitter and receiver, which I can find it here. This is an emitter. I can connect like that, and that's a remover. Now let's see. So once I play, I have this box is coming. hold on. Yep, that's okay. I hope the audible is fine, the audio signal is good. So we have this conveyor running, and these are the two sensors. Now here you can find out which sensor is on. So here this is on because of the because the height of the box is small. For smaller boxes we have just one sensor which is on. Okay, just in case if we have the bigger box like the one which is coming, this is going to detected by two sensors. So here you might have understand that we are sensing the number of boxes, or we are sensing the box passed by the sensor. If it is a smaller one, this is actually the medium one, only this sensor will be on. If the box is bigger one, both the sensors will be on. So this is actually telling you the height of the box along with the presence. Alright, so this is a bigger box, so for that both the sensors will be on. So this is the one way to use diffuse sensors in your application, just to sense the height of the box. Okay, the boxes are getting delivered by the aligner to the remover. So that was the example of diffuse sensor. Now we'll see some example of application of capacitive sensor. So we have a pallet here, and that's the conveyor. So what I'm going to do is I'm going to run this roller conveyor, and then we have here, you can see some capacitive sensors are installed. Alright, so I'm going to use this turntable as well to show you how this capacitive sensor is going to sense the box. So let's run this conveyor first. I need to play it. Oops, hold on a second. I need to change over its position. Now that will be okay. That's how quickly you can change the alignment of your conveyor. That's the benefit of using connector factory arrow. Alright, so now this is coming here, and this is my capacitive sensor. Hold on, let me just show you its signal here. So this is my capacitive sensor. Alright, so I'm going to run it again. So the moment this box comes in front of the sensor, this will sense it and it will be on, like that. So at this moment the sensor is on because it is sensing this wooden pallet above this one. So I can further move this box here. For that I have to run this rollers. So I can run the rollers, and if I stop in front of the sensor, this will also be sensed. Right now this is not sensing, so I have to roll it more, and I have to show you here. So right now we still have a little distance. So at this point the sensor is detected. So this will tell you the extreme back limit of the pallet, that you should not take your pallet after this point. You should not take your pallet. Alright, so this is to limit the pallet up to this position only. Okay, so once again, if I take it back again, my front limit is sensed, and if I take it this way, my back limit is sensed. Okay, so this was about capacitive sensor, how you can utilize capacitive sensor to sense these objects. You must remember this can sense both metallic and non-metallic. And you might be wondering then why we use diffuse sensor. This is for the same principle. Generally the capacitive sensor are cost less than the diffuse sensor. So if you're here, you can see that the range is very less. The box is almost above the sensor. So you can save your cost by utilizing capacitive sensor in this application. Here diffusive can also be used, diffuse sensor can also be used, but because of the cost we can use capacitive sensor. And also because of the application. Here you can see that the distance is more than capacitive. So capacitive cannot be used in that application where we have used diffuse, but diffuse can be used here, but it's stupid to use here because you don't need that much length, so you may cost higher. So this was like how we can use capacitive sensor. Now let's go to inductive sensor example. So I have a crane in front of you. This is a crane. So what we can do here is this is the elevator, kind of elevator. This is the base of the elevator. Okay, so I can lift this upward and downwards. Suppose let me reduce this one. We remove all the tags. So what I can do is I can move it up and down, and you can see that I have installed some inductive sensor here. So this sensor is actually used to detect the position of this elevator. So right now if I show you its tag, this is on because this is sensing this plate. Its range is almost similar to capacitive, 0 to 100 mm, so it is sensing this plate. And if I show you the first floor, we have another inductive sensor which will be used to sense the position of this elevator again. Okay, then we have another inductive sensor here. So here we are using inductive sensor because this is a metallic object. Okay, so let me show you some elevator. Not this one. This is up and this one is down. I'll take its tag as well, this tag as well. Alright, so presently you can see that this inductive sensor 3 is on because this is in front of the elevator. Now I'll move this one up. So this goes up. The moment it passes across the sensor, this is off. So let me just take you over here. Now I'll move it up again. At this point, the sensor is on. So you can take any action. You can stop the elevator when the elevator reaches at the first floor or first stage of your elevator. Then you can even move it further to let sense this inductive sensor 2. So you can run it up and you can stop it here as well. The sensor has been positioned in such a way that if the sensor stops this elevator, it will stop exactly at the second floor. So you have to make sure your sensor should be aligned and should be present at the exact precise location, because most of the error comes because we place the sensor at incorrect location. So location of the sensor is again a very critical thing to understand, where you have to fix the sensor. Okay, so this was about capacitive to sense metallic and non-metallic, inductive to sense only metallic or the conductive, and diffuse sense all kind of objects. So in the next video we'll see some more details about light array emitter, how this works. It has 3 types of signals, and we'll see about retroreflective, this kind of sensors. Alright, I hope this video is quite resourceful for you to utilize sensors. If you have any doubt, you can post a comment. I'll get back to you. Thank you so much.